Node.js is an open-source, cross-platform runtime environment that enables the execution of JavaScript outside of a web browser. It's primarily used for building server-side applications and networking tools. Node.js supports the development of back-end services, commonly known as APIs. This stands for Application Programming Interface. These are essential for powering client applications such as web and mobile apps. So key features of Node.js. One of the key features is its versatility in back-end development. Node.js is suited for creating highly scalable, data-intensive, and real-time applications. Its non-blocking, event-driven architecture allows it to handle numerous, simultaneous connections with high throughput, making it an excellent choice for developing services like chat applications and online gaming servers. The second feature is that it is quick to start and agile-friendly. Node.js is known for its ease of use and minimal setup, enabling developers to quickly start building applications. This attribute aligns well with agile development practices, where time to market and adaptability are critical. Another feature is real-world usage. Prominent companies such as PayPal, Uber, Netflix, and Walmart leverage Node.js in their production environments. These organizations have reported benefits such as reduced development time, decreased number of code lines and files, which in turn contribute to enhanced performance in terms of request handling and response times. Another feature of Node.js is that it enables you to use JavaScript for your backend and frontend. This allows developers to use the same language for both server-side and client-side scripts, promoting skill reuse and reducing the learning curve for new developers. It provides a uniform programming language across the stack, which leads to a clearer and more consistent codebase. Node.js also has a rich ecosystem. Node.js benefits from a vast ecosystem of open-source libraries available through NPM, which stands for Node Package Manager, which simplifies the addition of functionalities and accelerates the development process. In conclusion, Node.js is a popular choice for developers looking to build efficient and scalable web applications. Its ability to run JavaScript on the server side, along with its robust tooling and supportive community, makes it a dependable and practical choice for modern web development. What is Node.js? Node.js is a runtime environment for executing JavaScript outside of a web browser. So let's go over understanding runtime environments. A runtime environment is a setting where programs are executed. It provides built-in libraries and manages the program's execution, offering various services such as handling I/O or network requests. So JavaScript and web browsers. Historically, JavaScript was primarily used within web browsers. Each browser comes with its own JavaScript engine, which interprets and executes JavaScript code. So Microsoft Edge uses the Chakra engine, the Firefox browser uses the SpiderMonkey engine, and Google Chrome uses the V8 engine. These different engines can lead to variations in JavaScript behavior across browsers. Within a browser, JavaScript interacts with the document object model, otherwise known as the DOM, to manipulate web pages, using methods like document.getElementById, with the ID being root for this example. The evolution to Node.js. In 2009, Ryan Dahl, the creator of Node.js, proposed an innovative idea which was enabling JavaScript to run outside the web browser. He leveraged Google Chrome's V8 engine, known for its speed, and embedded it within a C++ program. This integration birthed Node.js, which is essentially an executable or a .exe program that extends JavaScript's capabilities beyond web browsers. So Node.js does not have browser-specific objects like the DOM because it is not intended for controlling web page content. Instead, it includes additional modules that provide JavaScript the ability to interact with the file system, create servers, handle network protocols, and more. For example, fs.readFile can be used for reading files from the system, and HTTP create server for creating a web server. These functionalities demonstrate that Node.js is equipped to handle backend services, making it ideal for building scalable network applications. What Node.js is and is not. Node.js is not a programming language. It uses JavaScript as its scripting language. Node.js is not a framework. It does not impose any specific way of organizing your project. It merely provides a runtime environment with useful libraries. Node.js is a runtime environment. It extends JavaScript's reach to the server side, offering tools and libraries that are not available in a browser context. In conclusion, Node.js revolutionized JavaScript's programming by expanding its scope from the client-side and browsers to include server-side applications. This advancement has made JavaScript a versatile, powerful choice for full-stack development. Node.js continues to thrive as a popular runtime environment due to its efficiency and the vast NPM ecosystem, which provides numerous libraries and tools to enhance functionality. Node.js operates on a non-blocking, asynchronous model, which can be likened to a highly efficient restaurant service. So let's consider a restaurant analogy. Think of Node.js like a single waiter serving multiple tables. Instead of waiting for one table's meal to cook before taking another table's order, the waiter keeps taking orders and serving food as it becomes ready. This demonstrates the asynchronous operations that Node.js supports. So now a technical explanation of this. In Node.js, when a request is made, the request is processed without blocking other operations. Node.js does not wait for the database response, but instead places a callback in the event queue, which will be executed once the response is ready. This allows the Node server to handle other requests in the meantime. Contrasting this with synchronous operations, in more traditional synchronous models, like those used by frameworks such as Ruby on Rails, each request might be handled by one thread. If the thread is busy, it cannot take on more work. This can lead to inefficiencies, as other requests have to wait until free threads are available or additional hardware resources must be provided. Synchronous operations have blocking behavior. In such synchronous environments, a thread handling a database query will remain idle until the data is returned, which is inefficient compared to Node's asynchronous approach. So let's go over the benefits of the Node.js model. The first benefit is efficiency. Node.js can handle numerous simultaneous operations on a single thread thanks to its event-driven model. This increases efficiency as the server can manage multiple tasks without waiting for any single task to complete. The second benefit is scalability. The ability to handle many requests on few threads allows Node.js applications to scale effectively without requiring significant hardware resources. This is particularly beneficial for I/O-intensive applications such as web APIs or real-time data processing. And the third benefit is resource management. Node's model promotes better resource utilization as the server remains active and non-idle even when data operations are pending. Let's consider ideal use cases for Node.js. Node.js is well suited for applications that require real-time data processing, such as an online gaming application, chat applications, and live streaming services. It excels in environments where the application needs to handle a large volume of short messages or commands that require low latency. Let's consider the limitations of Node.js. Node.js is less ideal for CPU-intensive tasks. For applications that require intensive data processing tasks, such as video encoding, image manipulation, or large-scale mathematical calculations, Node.js might not be the best choice. Its single-threaded nature means CPU-heavy tasks can block the entire system, leading to delays in processing other concurrent operations. In conclusion, Node.js leverages an asynchronous, non-blocking model to provide efficient and scalable solutions for many modern web applications. While it excels in handling I/O operations, it's less suited for tasks that are heavily CPU-bound. Understanding when and where to use Node.js can help developers maximize their application performance and efficiency. How does Node.js's asynchronous, non-blocking model improve server efficiency and scalability compared to traditional synchronous models? Node.js's asynchronous, non-blocking model improves server efficiency and scalability by allowing a single thread to handle multiple requests simultaneously. Unlike traditional synchronous models, where a thread waits for a task, like a database query, to complete before moving on, Node.js processes requests without waiting. It places tasks in an event queue and continues handling other operations. This approach prevents idle waiting, maximizes resource utilization, and allows Node.js servers to manage more requests with fewer hardware resources, making them highly efficient and scalable. What types of applications are ideally suited for Node.js, and what limitations should developers consider when choosing it for their projects? Node.js is ideally suited for applications that require real-time data processing and handle many simultaneous connections, such as online gaming, chat applications, and live streaming services. It excels in managing a large volume of short, low-latency messages. However, developers should consider its limitations for CPU-intensive tasks, like video encoding or large-scale mathematical calculations. Node.js's single-threaded nature can cause performance bottlenecks in such scenarios, making it less suitable for applications requiring heavy data processing. Node.js's module system is a powerful feature that allows developers to organize the code of large applications efficiently. Modules are discrete units of functionality that could be imported and used in other parts of a Node.js application, or even across different Node.js applications. So what are modules? A module in Node.js encapsulates related code into a single unit of functionality. This could be anything from a library of utilities to a set of related functions that handle specific functionalities, like database interactions, file operations, or network communications. So why do we need modules? Modules are essential for several reasons. One reason is maintainability. By dividing applications into smaller, manageable pieces, modules make the codebase easier to understand and maintain. The second reason is reusability. Modules can be reused across different parts of an application or even in different projects, which reduces code duplication and effort. The third reason is namespace management. Using modules helps avoid global namespace pollution by confining variables and functions within a local scope rather than cluttering the global scope. So how do modules work in Node.js? In Node.js, each file is treated as a separate module. Node.js provides a simple and efficient way to create modules and expose them to other parts of your application. So step 1 of creating a module, you can create a module by placing the code into a separate JavaScript file. For example, if you're creating a utility module, you might have a file named utility.js. So step 2 is exporting module contents. Node.js uses exports and module.exports to make functions and objects available to other files. For instance, if our utility.js file contains a function to check if a number is prime, you can export it like this. So implement a function, I'll name it isPrime. This accepts a number as a parameter, so I'll implement this. If the number is less than or equal to 1, return false. If the number is equal to 2, return true, since 2 is prime. Now if the number is divisible by 2, then we'll return false. Let n, we'll initialize that to 3. We'll take the square root of the number. So don't worry about memorizing this. This is just to demonstrate. So while n is less than or equal to the limit, if the number is divisible by n, then we know that it is not prime. So we'll update the value by 2. Only want to consider odd numbers. Otherwise, it is prime. So to make this function usable outside of this file or outside of this module, we need to export it. So we use the common JS syntax, module.exports is prime. So now, let me create another file, and I'll name this index.js. So step 3 is importing a module. So we use the require function to include the module in another file. So I can say const is prime, then the require function, I'll pass in a relative file path to the utility, and save that, utility.js. Now I can utilize that, and say log is prime, I'll pass in the number of 5. Let's bring up the integrated terminal, and I will run node index.js. So here we see the output of true, because 5 is prime. Let's do the value of 6, for example. We'll run it, and here we see the value of false. So this demonstrates how you would implement a function, export it, and utilize it in another file. So creating your own modules. Creating your own modules is as simple as writing any regular JavaScript file, and then using module.exports to expose parts of the module to other parts of your application. You can expose objects, functions, or any JavaScript data structure. In conclusion, understanding how to effectively use the Node.js module system is crucial for developing scalable and maintainable Node.js applications. By leveraging modules, developers can create well-organized, modular code that enhances code quality and development efficiency. How does the Node.js module system contribute to the maintainability and scalability of large applications? The Node.js module system contributes to maintainability and scalability by organizing code into smaller, reusable units, making it easier to manage, understand, and update individual parts of a large application without affecting the entire codebase. What advantages does the modular approach in Node.js offer in terms of code organization and reuse across different projects? The modular approach in Node.js improves code organization by encapsulating functionality into separate units, reducing complexity. It also enhances code reuse, allowing modules to be easily shared and used across different projects. In Node.js, global objects are special objects that are available in all modules. These objects provide essential functionality that can be accessed anywhere within a Node.js application, making them a fundamental part of the Node.js runtime environment. Let's cover the built-in global objects. Node.js comes with a set of predefined global objects that are readily available for use. These objects serve various purposes, from fundamental JavaScript objects to node-specific objects that provide functionality unique to the Node.js environment. The first one we will cover is the global object. This is similar to the window object in browsers. Global is the top-level object in Node.js. Almost all other objects are either properties of this object or derived from it. Let's consider the process global object. This is one of the most important global objects in Node.js. It provides information about and control over the current Node.js process. Through process, you can access environment information, read environment variables, communicate with the terminal, or exit the current process. The console global object. This is used to print information to the standard out and standard error. It acts similarly to the console object in browsers. The buffer global object. This is used to handle binary data directly. It is built specifically for managing streams of binary data in Node.js. Now let's consider global functions, which consist of setImmediate, clearImmediate, setTimeout, clearTimeout, setInterval, and clearInterval. These globals are timer functions that help you schedule tasks to run after a specified duration or at a regular interval. Creating your own global objects. While Node.js manages a variety of built-in globals, developers can also define their own global variables that need to be accessible throughout the application. Here's how to define and use custom global objects in Node.js. Step 1 is defining a global object. You can attach your custom properties or objects to the global object. This makes them accessible from anywhere in your Node.js application. So we'll use the global built-in object. We'll add a property, and I'll name this myConfig. Let's assign this to a JavaScript object. Close it with a semicolon. So we'll add the property API URL. We'll just do a sample URL of https api.example.com. We'll add another property, so at port 3000. Step 2 is using the global object. Once a property is attached to the global object, it could be accessed in any module without requiring imports or passing it explicitly. So we can log this out. We'll do log and then tab for that keyboard shortcut. Then we'll do global. Then that property we just defined, which is myConfig.API URL. Now I'll bring up the integrated terminal. So I'll use the keyboard shortcut of Command and J or Control and J. Now I've already navigated to where this file is in its directory. So I'll run node, and I name this file 5 global objects. And here we get our expected value, which is that API URL value that we added. So caution when using global objects. While global objects can be incredibly useful for sharing information across modules, their use should be minimized due to the potential for creating tightly coupled components and the difficulty in tracking changes throughout the application. It's generally better to explicitly pass objects you need within modules through module exports and require statements. In conclusion, global objects in Node.js are powerful tools for developing applications with shared functionalities. Understanding both built-in and custom globals can help you effectively manage application-wide settings and maintain state across various parts of your application. However, limited use of globals is recommended to maintain a clean and manageable codebase. How do built-in global objects in Node.js facilitate application-wide functionality and control? Built-in global objects in Node.js provide essential tools that can be accessed from anywhere in the application, allowing for easy control and management of the Node.js environment. They enable functionalities like process management, timing operations, and handling binary data without needing to import or define them explicitly in each module. This makes them crucial for application-wide tasks and system-level operations. What are the potential risks of using custom global objects in Node.js, and how can they be mitigated? Using global objects in Node.js can lead to tightly coupled code, making it harder to track changes and debug issues. Globals are accessible everywhere, so unexpected modifications can cause bugs that are difficult to trace. To mitigate these issues, it's better to minimize the use of globals and instead pass needed objects explicitly through module exports and imports. This keeps the codebase cleaner, more modular, and easier to maintain. Global objects provide essential functions and variables that could be accessed from anywhere within a JavaScript environment, whether in a browser or a Node.js application. Let's go over common global functions. The first one being console.log. This is a global function that outputs information to the console useful for debugging and logging application data. Second is setTimeout. This allows you to schedule a function to be executed after a specified delay. This function is very handy for executing code after a pause. ClearTimeout. This is used to cancel a timeout previously established by calling setTimeout. setInterval. This schedules a function to be run repeatedly at specified intervals. This is useful for tasks like updating the UI at regular intervals. ClearInterval. This stops the repeated execution set using setInterval. So let's cover global scope in browsers. In browser-based JavaScript, the global object is window. All global variables and functions are attached to this window object. Accessing globals. When you declare a variable or function at the global level, it's accessible through the window object, such as window.setTimeout or window.message. Global scope in Node.js. Node.js does not have a window object because it does not run in a browser environment. Instead, it uses a global object to provide a similar functionality. So let's discuss Node.js globals. In Node.js, you can access built-in modules and global functions through the global object, such as global.console.log or global.setTimeout. So an example of that, we are to global.console.log. This is a global console call, and that with a semicolon. Now if we were to run, let's save this and execute it, we get our expected console output. Now let's call setTimeout. setTimeout. So the first argument to pass is a callback function. So we'll specify an arrow function here. So I'll say log and then tab. I'll say this happens after a timeout. Now for the second argument, for the setTimeout global function, we specify the time in milliseconds. So I'll say 1,000. So after 1 second, we'll execute this again. We get our expected output, and then after 1 second, we see this console output. So both of these, setTimeout and console.log, are available globally. So let's further discuss variables and global scope. Unlike in browsers, if you declare a variable with the var keyword, let keyword, or const keyword at the global level in Node.js, it does not attach to the global object. This behavior encapsulates the variables within the module scope, avoiding unintentional conflicts. So for example, let's comment this out. If I were to do let message assign to hello world, and then we log that out, say global.message, clear this out with Command K, up arrow and run it, we see the value undefined. So even though this message variable was defined at the global level, it is not attached to the global object. So it is enclosed within this file, within this module. So let's cover an example using setInterval and endInterval. So we can comment this out. Let's define a function, and I'll name it updateTime. So we'll set the current date, so new date, and then we will log it out. So backticks to create a template literal. I'll say current time, and then a $sign in curly braces, now.to locale datetime string. So now we will write a comment, set an interval to run update time every second, right? So every 1,000 milliseconds. I'll say const interval ID, set interval, and we want to call update time every second. So this returns an interval ID, which we will use to cancel it. So we want to eventually stop the interval, and we'll do so after 5 seconds. So we'll call set timeout. Once again, the first argument is a callback function, so we'll use our modern arrow function syntax. And after 5 seconds, we want to clear the interval to stop it. And we need to pass the interval ID. Then we can log out. Interval cleared. No more time updates. Now for the second argument, we'll pass in 5,000 for 5 seconds. So let's run this. We'll clear this out. We'll run it. So it shows the current time every second. Then after 5 seconds, we see interval cleared, no more time updates. So let's discuss best practices. While global objects and functions are extremely useful, you should limit their use. Reason being is you want to avoid polluting the global scope. Adding too many objects to the global scope can lead to conflicts and difficulties in maintaining the code. It's generally better to keep global usage minimal. Second is you want to use local scope where possible. You want to encapsulate variables and functions within a local scope, such as within functions or modules, to avoid unintended interactions and make the code easier to manage and debug. In conclusion, global objects and functions are fundamental in both browser and Node.js environments, providing developers with powerful tools for performing common tasks. Understanding how to use these tools effectively and responsibly is crucial for developing robust applications. How do global objects differ in scope and behavior between browser-based JavaScript and Node.js environments? In browser-based JavaScript, the global object is the window object, and global variables and functions are attached to it. In Node.js, the global object is named global, but variables declared with the var keyword, let keyword, or const keyword are not attached to it. Rather, they are scoped to the module, or in other words, the file that they are defined in. This difference helps prevent global scope pollution in Node.js, making it easier to manage variables and avoid conflicts. What are the best practices for using global functions and variables in JavaScript to maintain code quality and avoid conflicts? Best practices for using global functions and variables in JavaScript include minimizing their use to avoid polluting the global scope, which can lead to conflicts and difficult to maintain code. Instead, encapsulate variables and functions within local scopes, such as functions or modules, to keep your code organized and reduce the risk of unintended interactions. This approach helps maintain code quality and makes debugging easier. In JavaScript, defining variables or functions directly in the global scope is straightforward, but can lead to complications in larger applications. So let's consider the global scope in browsers. In a browser environment, when you declare a function or a variable using the var keyword at the top level, it is added to the global scope, which means it is accessible through the window object. So for example, if you were to use var sayHello and assign this to an anonymous function that logs out hello, you can access it with window.sayHello. So that will successfully call the function. Now, problems with global scope. While convenient, using the global scope can lead to several issues. The first being namespace pollution. The global namespace can become cluttered with too many variables and functions, making it difficult to track down where specific things are defined. The second problem is accidental overriding. If multiple parts of an application inadvertently use the global variable names, they can overwrite each other, leading to bugs that are hard to diagnose. For example, defining sayHello in multiple files will cause the last loaded script to override all earlier definitions. So for example, in file 1, if we have var sayHello set to anonymous function, and in file 2, we have a function with the same name. So here, if in file 2, if that is imported after file 1, then when we call sayHello, this will always log hello from file 2, regardless of expectations. So the importance of modularity. To mitigate the risks associated with global scope, it's essential to adopt modularity in your development approach. So let's cover modules in Node.js. In Node.js, every file is treated as a module, and anything defined within that file is local to the module unless explicitly exported. This encapsulation ensures that variables and functions do not inadvertently interfere with each other across different parts of an application. The benefit is that it is private by default. Variables and functions are private to their module, providing a clean namespace and preventing accidental interference. And second is explicit exporting. To make a function or variable available outside its module, it must be explicitly exported, adding a layer of control over what is exposed. So for example, in a Node.js file, if we define sayHello, assign this to an anonymous function, log, and then tab, and we just log out hello. To export it, we use module.exports set to hello. So we have to explicitly export it. So this function can then be accessed in another file by importing it. So we would need to use the require function, and then we can invoke it, which will properly call the imported function. So let's cover the advantages of using modules. The first is clarity. Each module has a clear purpose and scope, reducing complexity and enhancing readability. The second advantage is reusability. Modules can be reused across different parts of an application or even in different projects. The third advantage is maintainability. Changes in a module are localized, impacting fewer parts of an application and thus reducing the risk of bugs. In conclusion, avoiding global variables and embracing modularity is crucial in JavaScript development, especially in larger applications or when working in a team environment. By using modules, developers can ensure their code is organized, maintainable, and less prone to unexpected behaviors caused by namespace pollution. What challenges can arise from using the global scope in JavaScript, especially in larger applications? Using the global scope in JavaScript can lead to several challenges in larger applications, including namespace pollution, where too many global variables and functions make it hard to manage code, and accidental overriding, where different parts of the application unintentionally use the same global names, causing conflicts and bugs that are difficult to track down. This can result in code that is harder to maintain and debug. How does modularity in JavaScript help in maintaining clean and manageable code bases? Modularity in JavaScript helps maintain clean and manageable code bases by encapsulating code into self-contained units, which we refer to as modules. Each module has its own scope, reducing the risk of name collisions and accidental overrides. This makes the code easier to understand, debug, and reuse, as changes in one module are less likely to impact other parts of the application. It also promotes better organization and clarity, leading to more maintainable and scalable applications. So let's go over creating and managing a module in Node.js. In this lesson, we'll go through the process of creating a simple logging module in Node.js. This module will encapsulate all the functionality related to logging messages and can be reused in different parts of your application or even in other applications. So setting up the logger module. So let's create the module file. So here in this directory, which I named loading a module, so right click, and I'll name this logger.js. So second, we will add the functionality. So we want to specify the functionality we want to encapsulate in this file, otherwise referred to as a module, const URL, and assign to http mylogger.io/log. Then we'll define a logging function. We'll name it log. The parameter it will accept will be a message. So in a real scenario, you might send an HTTP request here, but in our case, we're just going to log to the console, and we're going to log this message. Now this function, as well as this constant, is only accessible within this file or within this module, so we want to make the module contents public. So once again, since variables and functions in a Node.js module are private by default, you need to explicitly export any data or functions you want to make available to other parts of your application. So for exporting the functionality, we would use module.exports to make the log function and the constant, right, this URL, available outside the module. So we would do module.exports, and we can name this export log, and assign this to this log function. We also do module.exports.url and set this to URL. Alternatively, you could rename exports to provide a more intuitive interface to module consumers. So rather than naming this URL, we could rename this to be endpoint. So let's cover some best practices for exporting. The first best practice is selective exporting. In real-world applications, modules can contain numerous variables and functions. It's crucial to export only what is necessary to keep the module easy to use and understand. This practice helps maintain a clean public interface. The second best practice is the stability of the public interface. The public interface of a module should be stable and not expose too many implementation details. This approach ensures that changes inside the module do not affect other parts of your application that depend on it. So now let's use the logger module. I'll create a new file in this directory, and I'll just name this index.js. So here we need to import it, so I'll say const logger, but I'll name it. I'll use the require function, and I'll use a relative path to where the logger file or logger module is. And now we can call that. So I'll say logger.log. I'll pass in the argument. This is a message, right? So when we call logger.log, I go back to logger.js. It is calling this function, which we exported. And I'll also log out. So I'll say logger.endpoint, which is this constant that we defined, and we named it endpoint when we exported it. So let's bring up the integrated terminal, and I'll run node index.js, and we get our expected console log output. So in conclusion, by creating modules in Node.js, you encapsulate specific functionalities and expose a controlled interface to the rest of your application. This modularity enhances code reuse, simplifies maintenance, and keeps your application organized. When designing modules, it's essential to consider what should be private to maintain module integrity and what should be public to ensure usability. What are the benefits of encapsulating functionality into modules when developing Node.js applications? Encapsulating functionality into modules in Node.js helps to organize code, making it more manageable and reusable. It allows developers to isolate specific functions or data, reducing the risk of conflicts and making the codebase easier to maintain. Modules also enable better code reuse across different parts of an application or even in other projects, leading to a more modular and scalable development approach. How does careful management of a module's public interface contribute to the maintainability and stability of a Node.js application? Careful management of a module's public interface in Node.js ensures that only necessary functions and variables are exposed, keeping the internal implementation details hidden. This reduces the risk of unintended interference with other parts of the application and makes it easier to update or refactor the module without breaking dependent code. It contributes to the overall maintainability and stability of the application by providing a clear, controlled, and stable interface for other modules to interact with. So let's cover loading modules in Node.js with the require function. Node.js uses the require function to import modules, which is a fundamental aspect of managing dependencies and modularity of your application. This system differs from how scripts are loaded in your browser and is specific to the Node.js environment. So let's cover the basic usage of the require function. When you need to use functionality defined in another file or module, you use require to load it. So here are the steps of how it works. Step 1 is loading a module. So to load a module, you pass the relative path of the JavaScript file to the require function. Node.js resolves the path and loads the module. So for example, you would have const logger. This would be assigned to require, and then you pass in ./logger. So in this case, the logger file is in the same directory, or in other words, the same folder. Node.js automatically assumes .js as the file extension if it's not specified. Second is accessing exported members. The require function returns an object that represents the exported API of the module. This object contains all the members that are exported from the module. So if we were to do console.log and then logger, this would output that function. You can then use these members in your application, like how we did logger.log and passing in the message. Best practices for using require. The first best practice is using the const keyword for requiring modules. It's a best practice to use the const keyword, as this prevents accidental reassignment of the module variable within your code, which can lead to runtime errors. So if we were to import that with const logger, attempting to reassign a constant will result in an error, helping catch mistakes during development. So if we were to assign it, for example, to the number 1, this will throw an error if logger is declared with the const keyword. The second best practice is utilizing tooling for code quality. Tools like JS-Hint can be used to scan your JavaScript code for potential errors and bad practices. Running JS-Hint on your code can help identify issues like improper use of variables before they cause problems at runtime. So on your terminal, you would run JS-Hint and the name of your file. So in this case, app.js. This tool will report problems related to your usage of JavaScript, potentially saving you from bugs that are difficult to diagnose. Exporting a single function. Sometimes you want to export a single function from a module rather than an object. This can simplify the usage of the module where only one functionality is being provided. So if we have our logger function, we can do module.exports and assign that to the log function. So we're exporting just the function. And then when we utilize that in your application file, we import it with const log and utilize the require function, and then we can simply invoke it by just calling log and passing in the message as the argument. In conclusion, the require function in Node.js is essential for modular programming, allowing you to include and use JavaScript files and modules efficiently. By following best practices for module loading and leveraging code quality tools, you can ensure your Node.js applications are robust, maintainable, and error-free. What role does the require function play in managing dependencies and modularity within a Node.js application? The require function in Node.js is crucial for managing dependencies and modularity by allowing you to load and use code from other files or modules within your application. It enables you to break your application into smaller, reusable components, making your code more organized, maintainable, and scalable. By importing only the needed functionality, require helps keep your application structure clear and modular. How can following best practices when using the require function contribute to the maintainability and reliability of a Node.js codebase. Following best practices when using the require function in Node.js, such as using the const keyword for module imports and keeping modules small in focus, helps maintain a clear and consistent code structure. This reduces the risk of errors, makes your code easier to understand, and improves its reliability. It also prevents accidental reassignment of modules and ensures that changes in one part of the code don't unintentionally affect other parts, contributing to a more maintainable and robust codebase. So let's go over how Node.js processes modules. Node.js has a unique way of handling JavaScript code, which differs significantly from how scripts are executed in a browser environment. So let's discuss module wrapping in Node.js. When Node.js executes a module, it does not run the code directly as written. Instead, it wraps the module code inside a function. This approach is not immediately apparent to the developer, but it is fundamental to how Node.js operates. So here's what happens under the hood. First is function wrapping. Each module is wrapped in a function before it is executed. The function wrapper helps to isolate the module from the global scope, which means variables and functions defined in a module do not pollute the global scope. So just to show an example of what this might look like, we'll have, in parentheses, then we define function, exports, then require, module, and we'll discuss this more in detail in this lesson. Just want to demonstrate a visual example of what this will look like. Directory name, then the function block. So your module code lives here. Let me rename this, lives here. So if we were to do, say, const x assigned to hello, then we can log this out. So when we define these two statements, so const x assigned to a string and then logging it out, Node.js will implicitly wrap this module code inside a function. So second is the module wrapper. The function that wraps each module takes several important parameters, which we specified here. So the first is exports. This is used to export module functions and variables. The second is require, a function used to import the exports of another module. The third is module, which represents the current module. Next is the file name, so 2 underscores, and then file name. So this refers to the file name of the module, and then directory name. So third is exporting from modules. You can add properties to exports or module.exports to make them accessible to other modules. Like in our previous example when we did module.exports.log and assign this to the log function, or we can do exports.log assigned to log. However, replacing exports entirely won't affect module.exports because exports is just a reference to module.exports. Using built-in modules. Node.js comes with a variety of built-in modules that provide rich functionalities like file system manipulation, HTTP server creation, and handling system paths. These modules are essential tools for Node.js developers and are thoroughly documented in the Node.js API documentation. So an example of using a built-in module, if we were to do const path, and then we require the path. Let's comment this out. Now we can get the path object. So I'll say path object assigned to path.parse. Then pass in file name. And let's log this out. Path object. Bring up our integrated terminal. We'll run this file. And here it outputs this object showing my current file. So in conclusion, understanding how Node.js executes module code and utilizes function wrapping provides a clearer picture of the runtime environment. This process ensures that global variables and functions from one module do not interfere with another, fostering a more organized and secure coding environment. Furthermore, Node.js built-in modules are powerful tools that extend the functionality of Node applications, enabling developers to handle a wide range of system-level tasks efficiently. How does Node.js module wrapping mechanism contribute to isolating module scope and preventing global namespace pollution. Node.js's module wrapping mechanism isolates each module scope by wrapping the module code in a function. This prevents variables and functions defined in one module from leaking into the global scope, reducing the risk of naming conflicts and ensuring that each module operates independently. This mechanism helps maintain a clean and organized codebase where global namespace pollution is minimized, making the application more secure and easier to manage. What benefits do Node.js built-in modules provide for handling system-level tasks and application development? Node.js's built-in modules provide powerful tools for handling system-level tasks such as file manipulation, network communication, and managing paths. These modules save developers time by offering ready-to-use, optimized functionality that integrates seamlessly with the Node.js runtime. By using these built-in modules, developers can efficiently manage system resources, build robust applications, and avoid the need to reinvent common functionalities, leading to more secure, maintainable, and performant applications. So let's go over retrieving system information with the Node.js OS module. When developing applications that require system-level data, Node.js provides a built-in module called OS, which allows you to gather information about the underlying operating system. So let's cover using the OS module. Step 1 is to import the module. So at the very start of our file, we'll say const, we'll name it OS, require, and the name of it is OS for operating system. So step 2 is to retrieve memory information. So the OS module provides several methods to get system information, such as os.totalMemory and os.freeMemory, which returns the total and free memory of the system, respectively. So we can do that. Const, I'll say total memory, os.totalMem, and then free memory, os.freeMemory. Let's log this out. So I'll say log, and I'll use backticks, say total memory, and then total memory. And then I'll do shift option and down arrow to copy this. And I'll say free memory. And let's just copy and paste it here. So open up the integrated terminal. So that's Command J. So let's run this file with node. And then the name of the file. So here I get the expected output. So this provides insights that are not typically accessible from client-side JavaScript code, which runs in the browser. So in conclusion, the OS module is a powerful tool in Node.js for accessing operating system level information. This can be particularly useful for applications that need to monitor or manage system resources. Using Node.js, developers can write server-side code that interacts directly with the operating system, offering capabilities beyond what is possible in a browser environment. This makes Node.js a great choice for building more complex, system-sensitive backend applications. How can the Node.js OS module be utilized to gather essential system information for applications that require insights into the operating system's resources? The Node.js OS module can be utilized to gather essential system information by providing methods to access details like total and free memory, CPU architecture, network interfaces, and more. This information is crucial for the applications that need to monitor or optimize system resources, especially in server environments where understanding the underlying operating system can help in managing performance and resource allocation effectively. The OS module allows developers to write scripts that interact directly with the operating system, offering insights that go beyond typical client-side capabilities. What advantages does Node.js offer for building resource-sensitive backend applications that need to interact with the operating system directly? Node.js offers several advantages for building resource-sensitive backend applications that need to interact with the OS directly, it provides built-in modules like the OS module, which allows access to system-level information such as memory usage, CPU details, and network interfaces. This direct interaction with the OS enables better monitoring, management, and optimization of system resources. Additionally, Node.js's non-blocking I/O model makes it well-suited for handling multiple tasks efficiently, which is critical in resource-sensitive environments. So let's go over understanding the Node.js file system module. Node.js provides a powerful built-in module called FS for interacting with the file system. This module is essential for reading from and writing to files on the server. So first you would import the FS module. So at the top of your script, you can do const fs require, and the name of it is fs for file system. Now let's discuss the methods in the FS module. So the FS module includes a variety of methods to handle file operations, which comes in two primary forms, the first being synchronous, which is blocking, and asynchronous, which is non-blocking. So for the first form, which is the synchronous methods block the execution of further JavaScript until the file operation completes. They are straightforward to use, but can significantly slow down your application, especially under heavy load. So an example of this could be const files, and then fs.read directory sync. So the pass in the current directory. We could do console.log files. So this will log all files in the current directory. Let's run this in the integrated terminal. So it's node, then the name of this file. So here we see all the files in my current directory. I'll clear this out with Command J. Now the second form is asynchronous methods. Asynchronous methods, on the other hand, perform operations in the background and accept a callback function that runs once the operation completes. This approach is non-blocking and allows Node.js to handle other tasks while waiting for the file operations to complete. So an example of reading directories asynchronously, below I can do pause, and also say async files, just to give it a different name. So fs.read directory. First argument is the current directory, and then it takes in a callback function. So I'll specify that to be an arrow function. So arr, and then files. So within it, if there is an error, then I will simply console log it. So error, and then else console.log will say the result files. So this will log the files once it's read. So let's comment this out for now. And let's see the output when we do so asynchronously. So once again, we get the same result, outputting all the files in my current directory. So best practices for using FS methods. The first best practice is avoiding synchronous methods in production. While synchronous methods are easy to use and understand, they should generally be avoided in production, especially for I/O-heavy operations. A Node.js process runs on a single thread, and using synchronous methods can block this thread, leading to performance bottlenecks when handling multiple requests. The second best practice is to prefer asynchronous methods. Asynchronous methods allow your Node.js server to remain responsive by freeing up the main thread to handle other requests while waiting for file operations to complete. This approach is crucial for maintaining performance in applications that serve many clients simultaneously. Exploring the documentation. For a complete list of available methods and additional details, visit the official Node.js documentation for the FS module. This documentation provides comprehensive insights and examples for both synchronous and asynchronous methods. In conclusion, understanding and utilizing the FS module in Node.js is crucial for performing file operations effectively. By preferring asynchronous methods, you can ensure that your Node.js applications remain efficient and responsive under load, making full use of Node.js's non-blocking architecture. What are the benefits and drawbacks of using synchronous versus asynchronous methods when performing file operations in Node.js? Synchronous methods in Node.js are easy to implement and use, but they block the execution of further code until the operation completes, which can lead to performance issues, especially under heavy load. Asynchronous methods perform operations in the background without blocking the main thread, allowing the server to handle other tasks simultaneously. This makes them more suitable for production environments, ensuring better performance and responsiveness. The drawback is that they require handling callbacks or promises, which can add complexity to the code. Why is it important to prioritize asynchronous methods for file system operations in production environments when using Node.js? It is important to prioritize asynchronous methods for file system operations and Node.js production environments because they allow the server to remain responsive by freeing up the main thread to handle other tasks. Asynchronous operations prevent the application from being blocked by long-running tasks, which is crucial for maintaining high performance and efficiently serving multiple client requests simultaneously. This helps ensure the application can scale and handle high loads without performance bottlenecks. So let's go over understanding events and Node.js. Node.js is built around an event-driven architecture, primarily using an event loop mechanism, which makes it efficient for I/O-heavy operations. So the core concept of events, in Node.js, an event signifies something that has occurred within the application. For example, when a server receives a request at a port, it's an event. The Node.js runtime handles this event by generating a response. So let's go over using the EventEmitter class. EventEmitter is a core class in Node.js used for handling events within your application. So here's how you can use it. Step 1 would be importing the EventEmitter. So first we need to import the EventEmitter from the events module. So name this EventEmitter, and I'll use Pascal naming convention, the require function, and then events. So step 2 is creating an instance. So EventEmitter is a class, and you must create an instance of this class to use it. So this instance will manage the events for your application. So we'll name our object emitter, use our new keyword to instantiate a new object. So step 3 is registering listeners. Listeners are functions that are called when a specific event is emitted. So use the on method to register a listener for an event. So we'll do emitter, then the method on. So we'll name the event. So this will be message log. Then we pass in a callback function. So I'll use the modern arrow function syntax. And we'll just log out to the console. And I'll say listener call. And save that. So step 4 is emitting events. The emit method is used to trigger an event. When this method is called, all registered listeners for the event are invoked. So we can do emitter.emit, and then we're using the same name of the event for this event to have occurred. So it's important to register listeners before emitting the event, as they will not be triggered retroactively. So let's bring up the integrated terminal, and we'll run this file. So here we see when we emitted this event, it called the event handler, which we passed in as the second argument here. So let's discuss event arguments. Events can also pass data to their listeners, and you can send multiple parameters to the listener function by passing them as additional arguments to emit. So here, we currently have an empty parameter list, but we can specify this to be arg, for example. So let's include that in our console log statement. Say arg. Now when we emit it, we can pass in an object. So I can say the ID is 1, and the URL is StevenCodeCraft.com. So now this second argument that we pass will be the argument that our event listener or event handler receives. So let's call this again. And here we see we successfully passed data to our event listener. So let's discuss the practical usage. EventEmitter is widely used in Node.js core modules like handling HTTP requests and web servers or reading files asynchronously. Developers can use this pattern to handle custom events in their applications, enhancing the modularity and separation of concerns. In conclusion, the EventEmitter class is a fundamental part of Node.js that helps manage events and listeners, facilitating the event-driven architecture that Node.js is known for. Proper use of this class can help you build robust and maintainable Node.js applications by organizing operations around the handling of various system and custom events. How does Node.js's event-driven architecture enhance the efficiency of handling I/O operations? Node.js's event-driven architecture enhances the efficiency of handling I/O operations by using an event loop to manage multiple tasks without blocking the main thread. When an I/O operation is initiated, Node.js can continue processing other tasks while waiting for the operation to complete. This non-blocking approach allows Node.js to handle many concurrent operations efficiently. Making it ideal for applications that require high performance and scalability in I/O-intensive environments. What role does the EventEmitter class play in managing events and listeners within Node.js applications? The EventEmitter class in Node.js plays a central role in managing events and listeners. It allows you to create and handle custom events within your application. By using EventEmitter, you can define events, register listeners that respond to those events, and emit the events when certain conditions are met. This helps organize your application around an event-driven architecture, enabling more modular, maintainable, and responsive code, especially in applications with asynchronous operations. So let's go over handling data with events in Node.js. When working with the Node.js EventEmitter class, it's common to send additional data about an event. This can help listeners perform their tasks more effectively by providing them with the necessary context. So let's cover emitting events with data. When triggering an event, you can pass data as arguments to the emit method. This data can be accessed by the event listeners. So first we will cover passing multiple arguments. While you can pass multiple arguments separately, it is generally more manageable to encapsulate them in an object, as we did in the previous lesson. So I'm going to make a copy of this, so Shift Option and down arrow. So in the previous example, we passed all the data encapsulated within an object, but we also can just pass them as an argument. So passing in the ID value and the URL. But this is less manageable as it has less context. So we prefer to use an object because the name of the property indicates what this value represents. So it's not just a magic number, right? It has more context. So by passing an object, you can include multiple pieces of data under a single event argument, which makes handling this data and listeners simpler and more organized. Let's clear this out. So now let's cover registering listeners to handle data. Listeners can be set up to receive event data. Here's how to define listeners that handle the data passed to them. So using a function to listen for events, you can define listeners using either traditional function syntax or ES6 arrow functions. Both methods allow you to access the event data passed from the emit call. So in the previous lesson, we used ES6 arrow functions. To copy this, we could also have used traditional function syntax. So remove that arrow, and this will work as well. So in both cases, the argument, right, so this parameter that we specified, also commonly called event args or simply E, represents the data object passed from the emit method. So I'll remove this and we'll stick with the more modern syntax. So let's go over a practical example, which is a custom logging event. So consider a scenario when you want to log custom messages. So you can set up a specific event for logging messages and emit data related to those messages. So we can comment this out since we don't need that right now. Emitter.on, and we'll name this event to be logging. We pass in an arrow function. This accepts parameter of data, and we'll log out. I'll say receive message, and we'll do comma data.message. So now we can emit a logging event with the message data. So emitter.emit, so the name of this event, which is logging, we'll pass in that data object, which has a property of message, and I'll just say hello. So I'll bring up the integrated terminal, Command J, and then the name of this file, we'll run it with Node, and I get the expected console output when we call emit for this event to occur. So here the logging event is configured to pass an object containing a message, and the listener logs this message when the event is emitted. So in conclusion, using EventEmitter in Node.js to handle events with additional data is a powerful pattern for developing modular and responsive applications. By encapsulating data in an object and passing it through events, your application can maintain clear and manageable communication between different parts of your system. This approach not only keeps your code organized, but also enhances its flexibility and scalability. How does passing data through events improve communication and modularity within a Node.js application? Passing data through events in a Node.js application improves communication and modularity by allowing different parts of the application to interact efficiently. It's able to do so without direct dependencies. It enables event listeners to receive relevant data when an event occurs, promoting a clear separation of concerns. This modular approach makes the code more organized, flexible, and easier to maintain as components can respond to events and handle data independently. What are the benefits of encapsulating event data in an object when using the Node.js EventEmitter class? Encapsulating event data in an object when using the Node.js EventEmitter class provides several benefits. It allows you to pass multiple related pieces of data as a single argument, making the event handling code more organized and easier to manage. This approach also enhances readability and scalability, as the object structure can easily be extended to include additional data without altering the function's signatures or logic. It simplifies the communication between different parts of the application, ensuring a cleaner and more modular design. So let's go over integrating EventEmitter into custom classes. In real-world applications, it's uncommon to use EventEmitter directly. Instead, you typically extend EventEmitter in a custom class to encapsulate related functionalities along with event handling capabilities. Extending EventEmitter allows you to build self-contained components that can generate events and handle their own functionalities. This is particularly useful for creating modules that need to perform actions and then notify other parts of your application that those actions have completed. So we'll go through the process of creating a logger class that extends EventEmitter to handle logging operations and emit events. So step 1 is defining the logger class. We'll create a new directory, and I'll name this 15 custom class EventEmitter. So in this directory, I will create logger.js. Let's import EventEmitter. This will be the base class, and that is from events. So now we'll define our custom class, which is logger, and we want to extend the functionality because logger is in an event emitter. Extends event emitter, so it inherits all of its functionality. So now let's define our log method. The log takes in message as its parameter variable. I'll add a comment here and I'll say logic to log an HTTP request or any message. So then I'll do console.log of the message. I'll add another comment, so I'll say emitting an event when the log method is called. So I'll say this, so this current object, I'll call emit. Since logger is an event emitter, we inherited this emit method for to call or invoke an event. This will call the event logged event, and we'll pass in the ID and the URL, which I'll say is StevenCodeCraft.com, just for example. Now, once again, this class is only available within this file or within this module, so we need to explicitly export it. So I'll say module.exports onto logger. So we're exporting this class. I'll create a new file here. I'll name it app.js, and we want to utilize this logger class we just defined. Let's import it. So logger require It's named logger. I'll instantiate it. All right, so we're creating a new instance of that logger class that we defined. I'll add a comment here and I'll say registering a listener for the message log event. Right, so we need to define this event and listener before we call it. Right, so we named it message logged. So I'll say logger.on message logged. For the second argument, it takes the callback function. So we use the modern ES6 arrow function syntax. Log to the console, and we will log out listener received. It's an argument. And now let's actually call that log function. So I add a comment here. I say calling the log method, which will trigger the message logged event. Right, so we're calling this method that we defined here. So I'll say logger.log of, I'll just say hello world. Let's bring up the integrated terminal. Then I'll navigate to this directory that I created. It's 15 custom. And now I'll run node app.js. So here we see it logged out. We'll go to the implementation of this. It logged out the message, which was hello world. And then it logged out what we had in this event listener. So listener received, and then the data that we passed to it. So let's go over the benefits of this approach. The first benefit is encapsulation. The logger class encapsulates both the logging functionality and the event handling, making it modular and easier to manage. The second benefit is reusability. By abstracting the EventEmitter behavior into a class, you can reuse and extend this class wherever needed without rewriting the event handling logic. The third benefit is maintainability. Having a dedicated class for logging and event emission helps maintain and modify logging behavior independently from the rest of your application. Let's go over a common mistake. So a common mistake when starting with EventEmitter is to create multiple instances of the emitter when only one is needed, or to bind listeners to different instances than the emitter that emits the event. This is why encapsulating the event emitter within a class, as shown, ensures that the event listeners are correctly associated with the specific instances of the class that emits the events. In conclusion, by extending EventEmitter in custom classes like Logger, Node.js applications can handle complex functionalities while efficiently communicating events across different modules. This pattern enhances the modular architecture of the application, promoting clean and manageable code that adheres to modern software design principles. What are the advantages of integrating the EventEmitter class into custom classes when building modular components in Node.js? Integrating the EventEmitter class into custom classes in Node.js allows you to build modular components that can handle specific tasks and emit events related to those tasks. This approach encapsulates functionality and event management within a single class, making the code more organized, reusable, and easier to maintain. It ensures that event handling is tightly coupled with the relevant functionality, improving the overall architecture and communication between different parts of the application. How does extending EventEmitter in custom classes enhance the reusability and maintainability of Node.js applications? Extending EventEmitter in custom classes enhances reusability and maintainability by encapsulating both functionality and event management into a single, self-contained module. This allows the class to be easily reused across different parts of an application or in other projects without duplicating code. It also simplifies maintenance because the logic for emitting and handling events is centralized, making it easier to update or modify without affecting the rest of the application. So let's cover creating a web server with Node.js. Node.js provides the HTTP module, a powerful tool for developing networking applications, such as web servers that listen for HTTP requests on a specified port. let's cover the basic web server setup. So the first step is to import the HTTP module. The HTTP module includes the functionality necessary to create server instances. So we can do const HTTP require HTTP. So the second step is to create a server. Use the createServer method to create a new server. This server can handle HTTP requests and responses. We do const server assign to HTTP createServer. Step 3 is listening to events. The server object created by HTTP createServer is an instance of EventEmitter. This means you can listen to events like connection for lower level network events. We could do server.on the event of connection, and we'll pass in our callback. So the parameter will be socket, and we're using our modern ES6 arrow function syntax, ended with a semicolon. And for now, we'll just log to the console, new connection, and save that. So step 4 is starting the server. We'll have the server listed on a port, such as 3001, to handle incoming requests. So we could do server.listen at 3001, and we'll log out to the console, listening on port 3001. So now let's run this in an integrated terminal. So here we see it's listing on port 3001. If we navigate to our web browser, so now if I navigate to localhost 3001, let's resize this. Back in VS Code, we see it says new connection, which is this console log statement here. Close this out, and Control-C to stop this program. So handling HTTP requests more efficiently. While the above method works for simple demonstrations, handling HTTP requests based on different routes can be done more effectively. So step 5 would be refining the server to handle requests. Instead of listening to the connection event, you can directly handle HTTP requests by providing a callback to createServer that deals with requests and responses. So here, where we called createServer, we pass in the callback function, so the request and the response, using our arrow function syntax. So if the request URL is at the index, right, so just a /, we can do response.write hello world, and we will end the response. Otherwise, we can say if request URL is at API courses, we can say response.write json.stringify. We'll just say an array of 1, 2, or 3, and response.end. So let's run this again. Up arrow, run. So once again, it's listening on that port. We can navigate to it. I'll say localhost 3001. And here we see hello world as specified when we did response.write. Now if we navigate to this path, we'll add this to the end. And here we see this array that we specified here. So this setup directly responds to HTTP GET requests at the root with the /, as well as at API /courses, which sends a JSON response, in this case, an array. Let's close this with Control-C, close it out. So using Express for complex applications. For more complex web applications, managing routes with the native HTTP module becomes cumbersome. This is where Express, a web application framework built on top of the HTTP module, comes in handy. So let's discuss the advantages of Express. The first being simplification of routing. Express provides a much cleaner and organized way to handle different HTTP routes with minimal effort. The second advantage is middleware support. Express allows you to use middleware to respond to HTTP requests, handle errors, and process data. And third is enhanced server capabilities. While Express uses the underlying HTTP module, it simplifies many tasks and adds powerful new features. Now to discuss what an example of this might look like, you need to utilize the Express npm module and create a package.json file. After you import Express, you can create an instance of it by calling Express. Then you can define the GET request, for both the root path as well as the API/courses path. So in conclusion, starting with Node.js's HTTP module is great for learning the basics of network communications in JavaScript. However, for building more sophisticated applications, such as a framework like Express, can greatly simplify your code and enhance your server's functionality, making it easier to maintain and expand. What are the benefits of using the Node.js HTTP module to create a basic web server, and when might you consider using a framework like Express instead? Using the Node.js HTTP module to create a basic web server is beneficial for learning the fundamentals of network communication and handling HTTP requests directly. It offers full control over the server's behavior with minimal overhead. However, for more complex applications, a framework like Express is preferable because it simplifies routing, supports middleware, and adds powerful features, making the development process faster, more organized, and easier to maintain as the application grows. How does the event-driven nature of Node.js influence the design and functionality of a web server created with the HTTP module? The event-driven nature of Node.js influences the design and functionality of a web server by allowing it to handle multiple requests concurrently without blocking the main thread. This non-blocking I/O model ensures that the server can efficiently manage incoming connections and process requests as events, responding to them asynchronously. This design is particularly well suited for high-performance applications, where the server needs to remain responsive and scalable even under heavy load. So let's summarize what we covered for the Node module system. First, we covered an introduction to Node.js. This part of the course provides a foundational understanding of what Node.js is and the benefits of using it. Then we covered Node.js's architecture. We explained the internal architecture of Node.js, including its non-blocking, event-driven nature that allows for high performance across real-world applications. We did a deep dive into Node.js functionalities, where we covered how Node works. So we learned more about the underlying mechanisms that power Node.js, such as the event loop and asynchronous programming. We covered an introduction to the Node module system, where we discussed the modular structure of Node.js applications, emphasizing how modularity is achieved and managed. We covered working with Node.js modules, which includes global objects. So this covers built-in global objects in Node.js, which are accessible across all modules. Covered modules, and focused on the importance of modules in Node.js for organizing and maintaining code. We went through creating and loading modules, and we covered practical guidance on how to create your own modules and how to import existing ones. Module wrapper function. This section covered how Node.js wraps module code within a function to maintain module scope and privacy. Then we went through and covered specific Node.js modules, starting with the path module. So this introduces utilities for handling and transforming file paths. The OS module, which provides information about the computer's operating system where the Node.js application is running. The file system module. So this demonstrated how to work with the file system for reading from and writing to files. And the events module. So we discussed the EventEmitter class and how to handle custom events and applications. We went through more advanced topics by covering event arguments, which detailed how to pass and handle data with events using the EventEmitter. Then we extended the EventEmitter, where we learned how we can enhance and customize the EventEmitter for more complex event handling scenarios. Lastly, we covered the HTTP module. So this outlined how to use Node.js to create web servers and handle HTTP requests effectively. In conclusion, this section covered the fundamentals of how to use Node.js and its module system for building scalable and efficient applications. By understanding and utilizing the core modules and architectural principles of Node.js, developers can create robust backend services and applications suited for a variety of real-world tasks.